Okay, I usually don't blow out people's eardrums when I'm talking. I do raise the volume up. That's just the way I am, but I'm being recorded here. I got a microphone on, so I'm hoping everybody can hear me clearly. My name is Kevin Witt. I'm National Weather Service meteorologist. I've been with them this is my 11th year with them. Before that, I was with the private sector for 9 years, forecasting mostly maritime interest, ships and oil companies and so on. But I've taught a number of these classes. I'm sure everyone here, most everyone, if all but maybe one, you don't have to raise your hand, has taken the Basics 1 course, the long 2 to 2.5 hour course of the basics of what meteorology and aspects we're looking at as a National Weather Service employees and forecasters to better improve our warnings and watches. This class is structured primarily on the winter storms. I don't think you're going to see anything tropical, flooding related. If you do, it might be at the very end, it might be one slide, but nonetheless, we're going to hit a lot of winter storm topics, everything from directions, what we're looking for, what we want you to report to us, some facts, some statistics, some climate stuff. So there's a lot of information, trying to squeeze this in 2 hours. I'll wait a little bit longer for a few people coming in later on. And I just want to make sure that everybody can get as much information as they can from us. Rather than speed talking here, I will hit on a lot of the main points on each of the slides. Some of these you may have seen before. If you've taken this winter storms course as a refresher, there might be a few new slides for you to see. We'll get through most of this. I'm trying to end it around 8, maybe a few minutes after, and let's just begin. If you have any questions, raise your hand. If I see too many hands or if there's a lot, then maybe what I'll do is I'll hold off until after the class to answer a few questions, and also I'm available by email and by phone. So please don't get discouraged if I answer a couple questions and then I don't get to you. Don't worry about it. We'll get to it. So there's a lot of information here. I looked over this before I came up here, and it's just a lot to cover on some information. What we want takeaways from this, what we want for you as storm spotters, is what we need from you as a storm spotters and ground truth, what to report in great details as possible, just like you would give us your spotter number, your location, and what winter precipitation we want to get from you. So let's begin. Today's topics, we're going to be reporting procedures, what we want from you, measuring snowfall, how to measure, what to use, winter storm ingredients, winter hazards, NWS products and services that we provide, a 2014 case study that we've done, and preparedness and safety. Reporting criteria for winter storms. Snow accumulation. Every 2 inches or any accumulation not reflected in the forecast. We may have a mix of rain and sleet, but no mention of snow. We may just have rain and freezing rain, but all of a sudden it's snowing at your place. Give us a call, let us know, hey, I noticed the forecast, you have rain and freezing rain, but I've already got an inch of snow on the ground, it's coming down really hard. That usually doesn't happen, but it can, and it probably will in the next couple of years, because obviously to really hit on the mixed precipitation batch of snow, sleet, freezing rain, and rain, it gets tricky looking at all layers of the atmosphere, and we want to know from you what you're getting if our forecast is off a little bit. Otherwise, if it starts snowing, here's where you come into play. We want you to take measurements with a snowboard. You're going to see snowboards up here. You're going to see instructions on what to do. Every 2 inches. So it starts snowing, you get to 2-inch mark, give us a call. The next 2-inch mark, you reach the 4-inch mark, give us a call, and so on. So this way we can keep track of snow intensity, where it's falling the heaviest at, and how we can adjust our forecast. Reporting criteria for winter storms. Here's 2 images here. There's been some discrepancies on, well, is it sleet? Is it freezing rain? When you see the accumulation like this, the left picture is the ice on the car window example. You can see a nice gleam of ice coating over the windshield. The one to the right, it looks like more spotty. There's granular texture to it, while it's smooth in other places. There's your sleet on a car. So ice, which could be freezing rain, where the temperatures are below freezing, it's raining, it's making contact with windshields, vehicles, guardrails, and so on, and it's accumulating. The one on the right is the sleet accumulation. And you can get sleet and rain, a mixture, mostly sleet, and then all of a sudden you get this kind of scenario where the sleet adheres to the location. So ice accumulation, basically any amount. Make sure to differentiate between the sleet accumulation and the ice accumulation. Snowfall reporting and measurement. To the left, you can see the snowboard. That's a board about 2 foot by 2 foot, painted white if it's not already white, for the sake of albedo issues. We don't want the snow to melt faster than what It's the environment's making it. Obviously a black body, a black board or red board, anything other than white could melt the snow a little faster, especially if you get some sunshine, direct sunshine on that. So please find a white board. It can be plywood, formica, anything white if you're going to take measurements. Also, to the right, you want to mark it. Obviously, you get anything greater than a couple inches, you're going to find out you're not going to find your board. You may have an idea where it's at, but in order to make that accurate snow measurement without scuffling through the snow trying to find it, you want to mark it with something, whether it's sticks, stakes, metal, plastic rods, something like this. And this is what we do at our office. We actually have two boards placed like that, pretty close to one another. One is the 6-hour snow measurement, and the other board we do is snow depth. So snow depth throughout the entire winter season versus the 6-hour snow measurements where you would clear it off. So these are the two pictures to really take into account: the color of the board and marking them in the snow so you know where to find them. So if you clear your board, no more than every 6 hours. Why? Because we'll get miscalculations on what actually is falling in terms of snow accumulation. We want it to be as accurate as possible. So based on snow settling, melting, the combination of the two, sunlight, no sunlight, the best thing to do if you're clearing your board, do it every 6 hours. So get into a routine that if you're taking measurements for us, the 2 p.m., 8 p.m., 2 a.m., 8 a.m., and in that mindset, then you would clear your board and report whatever it was. That's one of the more important things, and that's often sometimes can be confused, and a lot of people want to, they get a big burst of snow or a snow squall, and they go out and measure, and then they clear the board telling us what they've got, but they forgot, oh, I have 3.5 more hours until I'm supposed to take my next observation. So therefore, what falls after that may not be an accurate representation of snow depth. It may be, you may be off by a half inch, quarter inch, even an inch. That's why we want to get everybody focused on no more than every 6 hours. Don't do it as free. Only 6 hour increments to get a better representation and accurate of snow measurements. So obviously you want to replace the board on top of the snow, not back in the hole, because you might have the issue of drifting. The board might not be level. You lay the board down and some snow falls on it, and you might not realize that. That could be an inaccurate measurement. So say we get a foot of snow. You take the measurement. You can move the board off to the side where the snow has not been disturbed and then replace your rods. But the bottom line is you don't want to put it back in that little canyon, so to speak, of snow. And also clearing the board off every 6 hours is pretty important. Reporting and measurement: report snowfall the first 2 inches, as I mentioned. Then every 2 inches after that. Total snowfall, is it measured or is it estimated? You may have to estimate based on drifting or drifting snow. Maybe there was some rainfall that fell. That's fine. Rain or sleet may cause the snow amounts to be less. That's totally fine. But remember to tell us if you used if you used a ruler, a yardstick, or just looked at it and got an estimate on how deep it is. So first 2 inches, every 2 inches after that, measured or estimated. Now reporting ice accumulation, a glaze of any kind. Say the concrete sidewalk is icy, but the pavement is just wet. Let us know that. And one way to measure on branches of trees, you can take little tree limbs and see for yourself like roughly how thick that ice is by taking the end, breaking it off, and looking at how thick it is and measuring it with a ruler, basically measuring the radius, so we can kind of get an idea, well, how much ice is accumulating in your area. Thickness is usually in fractions of an inch. You can say 1/16, 1/4, or 1/4 of an inch of ice is a lot, so you really need a good storm. And we can get that, and we've forecasted that before in this general region, but a lot of times those are the big ice storms in March that you'd see in the southern plains of a half inch of ice and then snow on top of it. But we want you to try to get an idea of how to measure the ice by looking at the radius of a branch or looking at the guardrail, knock a little bit off the guardrail and kind of give us an idea. Oh, it looks like about 1/8 of an inch, half of a 1/4 inch, something like that. Let us know. God bless you. Report a change in precipitation type. If it's snowing like crazy and you've reached 2 inches and you let us know, and then 15 minutes later after you get off the phone with us, it's all rain. Well, keeping that in mind with measuring your snow, but let us know too that, I've gotten 2 inches of snow. I called you 15 minutes ago. Now it's changing over to all rain. That's good to let us know that, because we may not have you changing over to rain till evening, and here it is 1 p.m. That's going to play a huge difference on our snow amounts. Our snow amounts, ice amounts are going to be reflected into our watches, warnings, and advisories. And then obviously people hearing the word warning, they're thinking, oh my goodness, versus a watch where it's like, okay, so that makes a big difference on, snow amounts, ice amounts. Let us know if there's a transition period, snow to rain, rain to snow, sleet and freezing rain over to snow. Anything like that could greatly help us. You can also measure snow on an outdoor wooden table or deck. As an example, as I mentioned, I showed you that one picture of the snowboard on the ground measured by 2 stakes. This gentleman here worked at our office. He retired a couple of years ago. You can see he's holding a meter stick. And that isn't actually a plowed snow. This may actually be a plowed snow, but what we wanted to get at on this is the snow that he measured, not in this particular location, set the West Virginia state record for snowfall for the season in terms of snow depth. Snow depth versus snow accumulation. Snow accumulation, wipe the board after 6 hours. Snow depth, let it accumulate. It's going to fluctuate, it's going to settle, you're going to build up on it, and so you can record that throughout the entire season. But this was a record snowfall back then. We originally had a picnic table outside of our office doing that, but then we found a better location just outside our office to put those 2 snowboards versus a picnic table. But if you don't have a lot of area, it's tough to find a table. You also may have some drifting. You may find a place in your backyard but it's close to your shed and close to your house. Set it as far away from obstacles as you can to allow the snow, even if it's blowing, to accumulate on those boards. So in drifting issues, take several measurements. Discount the very high and the low end. So if you take 3, 5, 7, 9, whatever you take, you're going to get various numbers. You want to roll out the high one and the low one, take the average of the ones in the middle, and let us know what you've got. That's pretty much the best way to measure drifting snow. Use these rules and do your best. In windy snows, measuring snow is definitely challenging. As we've had a blizzard in this area back in 2010, we had 3 major storms in the 09 and 10 season. One of them was a blizzard where it was 30 miles per hour winds sustained for a long period of time, and we're trying to measure even at our office. It's tough because it turns out it's snowing like crazy, but we go out to measure after 6 hours to clear the board, and there's only about a ½ inch on there. And we know for a fact, based on radar, satellite, and the storm system position itself, we had a lot of snow, and we didn't get a ½ inch. So that's where we went into the drifting aspect, trying to see where the snow accumulated and what we've got. So that makes it challenging. Snowfall reporting, changing precipitation types, as I mentioned. Here's a radar imagery of, this is a dual pole radar. The snowy texture to it, the yellow, the greens, the purples, magentas, that's kind of a mix of probably some sleet and snow. When you get up to looking at this image in Long Island Sound, northern Long Island, north of KOKX, that's all one particular precipitation type. So dual pole radar can tell us a mixture of snow, sleet, freezing rain. It can tell us all snow. It can tell us all rain, just like it helps us with hail and thunderstorms. So dual pole radar helps us better understand the winter precipitation types. This is what this image is what we call the correlation coefficient. The dual pole has 8 different segments of radar imagery that it gives us, and combining the 8 or taking partials, 4 of the 8, 6 of the 8 can tell us a lot on whether it's a rain snow line, snow, all rain. How to report the information. Many of you who have taken the basics class have these numbers probably in your phones, on paper, in your head. The 800 number, 253-7091, 703-996-2200. Just an FYI, the first one goes directly to us. The second number, the 2200 number, goes to a phone recording for forecasts, river forecasts, coastal forecasts. You want to reach us directly, either dial the 7091 number or that 2200, just make that last 0 a 1. 2201 will go right to one of us at the office. Because obviously if you're trying to get a snow report to us or an ice report, you're going to get a recording if you dial the 2200. So that's the first and foremost way of contacting us, storm reports. Second, because it's snow, sleet, freezing rain, if it's not a major coastal storm, emailing is fine too. lwx-report@noaa.gov is our email. Let us know either one way, shape, or form. There's also a form to fill out too for our spotters that we've created about 2-3 years ago, where you can put your snow and ice reports in. You put your spotter number, your name, your location, what you're reporting. I think you'll see that form up. We have that form in one of these slides, I believe, but it's a link that you'll type into your web browser and it comes up, to that. Or you go to our SkyWarn page, SkyWarn off of weather.gov/LWX, and click on the link there. Now, one of the fourth ways is contacting local emergency manager if there's issues, storm damage, snow piling up on a building, collapsing a building, someone getting injured, or a mixture of, say you have thunder snow, lightning can hit power poles and trees and cause damage in a major snowstorm, so that's a possibility. And an amateur radio, when activated, we will activate SkyWarn. Amateur radio hams are usually helping us out quite a bit, either at the office or remotely, to let us know what's going on. So there's 5 ways to report information, not just from winter aspect, but also your severe weather and flooding aspects. New snow ice reporting. This is new for this winter coming up. Filling out the snow and ice report form. The link, I'll leave it up there for a few extra seconds here. HTTP, then you have your ht.ly/G_VPW. I know it's kind of, I wish it was an easier way to remember this, but if you write it down or put it in your phone or take a picture of it, that would help you. And if you go to that site on the internet and you don't get to it, go to our webpage, weather.gov/LWX, and go to SkyWarn, the SkyWarn icon at the bottom, or just click on search for SkyWarn, and this link should be on there too. So that's another way to get this link. Reports will automatically get submitted into our database. So once you go to this link and you put in my SkyWarn Spire number is HW120, and I've gotten 3 inches of snow, heavy snow currently, mixed with sleet. Maybe in the comments section there's a mix with sleet in the last hour, and then we'll see this form. The numbers, the detail, like your spotter ID, will go into our database automatically. And then what we do when we get a few seconds when a busy snowstorm, we go in and just look at it and make sure there's no typos. Somebody might have reported, one of you might have reported 3 inches, somebody else may have reported 4.5, somebody reported 2.5, and then all of a sudden we see one that says 18. That may have been a mistake. It could have been 1.8 inches. So that's why we QC a lot of this data. But this link will get you into that form, and you can put that in automatically, and that helps us out considerably time-wise. This is what the form would look like. I should have put that up there a few seconds ago so you can visually see what I'm talking about. SkyWarn ID, and then your answer is like fill in the blank, observation, date and time, snow amount, your answer, ice amount, and then remarks. So this is a helpful form that was created to try to make things smoothly, faster. It gets super busy at the office. In severe weather season, phones ringing off the hook. Major winter storms, same thing. But when it comes to snow and ice, the timeliness on us receiving it versus tornadoes and flood and hail, and not as crucial. But this is just another way of quickly being in your home, being at your home in your seat and typing it in and sending it to us. Contact information, once again, the 1-800 number 253-7091. The web address, the email address, lwx-report@noaa.gov. And then there's our homepage, www.weather.gov/Washington. And then that link that I had up there in white letters, http ht.ly. So you have the link right there too. So if you take a picture of that or write that down, that's the contact information you're looking for. So mid-Atlantic winters, temperatures, you look at max temperatures, min temperatures, are the averages for the months, November to March. If you can see middle 50s in November, quickly middle 40s in December. We don't, this mid-Atlantic, we're talking like an area, a large area, Maryland, Eastern West Virginia, Virginia on average. We could really break it down into every single station. But in this case, extrapolate, it's going to be colder west and north versus south and east. But these numbers don't scream, hey, winter outbreak. But when you get temperatures that are borderline upper 30s, low 40s, you start getting concerned about mixing precipitation. Now, snowfall, we're less than a week away from October. So as you can see, average, DCA, Reagan, Dulles, and BWI trace. So we really don't get a good opportunity of seeing some snow in October. I have some other statistics here that you might find interesting, like the earliest snowfall was like October 10th, and that was recorded in the last several decades. But majority of our snow obviously is January, February, and early March, sometimes late December if we get into a strong El Nino pattern. For the season, as you can see, we average about 20 to 24 inches of snow. The record year we had broken records in 09 and 10. I think BWI, we had 77 inches for the season. So I was 50 inches above normal. That was a pretty significant winter season. Mid-Atlantic winters, normal temperatures. As you can see the bar graphs here, November, December, January, February. As you get into February, temperatures on average, they start rebounding a little bit, especially in the latter half of the month. As you get into March, you're getting more of a spring-like pattern, late winter, early spring. And average minimum temperatures, colder obviously in January, late January and February. Normals are based on a 30-year period. So this is what we're looking at here, Mid-Atlantic winters, normal temperatures. Mid-Atlantic winters, average snowfall, November. Well, there's the three major airports. You can see we don't really get much of an opportunity. To your left are your inches, 0 to 8 inches. February, obviously, is the big payoff, especially when you look at further north and west. BWI kind of sits in that area where you can get a little bit of an influence from Chesapeake Bay. You get the wind in the right direction off the bay. Snowfall can get downplayed really quick with regards of mixing with sleet and freezing rain or rain. So there's a little bit of a map, a little bit of a chart of what we're looking at in terms of Mid-Atlantic winters. Earliest measurable snowfall, all airports, BWI closest to here, 0.3 inches, and that was on October 10th, 1979. Which is a little more than 2 weeks away. So yeah, from what I saw, a long-term pattern, I didn't see anything that could bring us any snow period till that point. I don't think it's going to change that dramatically. We're going to get into a pattern where storm systems are going to ride by, less severe weather, more chances of showers, cold, and then warm again, maybe a few more showers. So nothing that I can see digging like an upper level disturbance that's going to bring us some snow October 10th. I mean, things do change, models do change. We use dozens of models for forecasting. But in this case, latest measurable snowfall, the latest in the year, you can see it snowed and accumulated as late April, BWI and DCA, early April, Dulles. Now, Dulles records only go back about 50 years. DCA and BWI go back decades before that. So, don't be surprised, like, why is Dulles much more than BWI? Well, records were only started getting kept, I think, in the late 60s from Dulles. Average annual Mid-Atlantic snowfall maps. I think most of you can see we have the big numbers up there, so you can probably see those. We're looking at 80 to 110 inches out in the mountains, western Maryland, eastern West Virginia, and as little as a foot on average in southern Maryland. So big wide range that we have, and it really gets tricky when you start factoring mixed precipitation, moisture off the bay, moisture off Potomac River. So that gets a little tricky in terms of seeing if those amounts are going to amount to anything. Mid-Atlantic winters, snowiest month ever. Reagan, 35 inches, a little over 35 inches, 1899. I believe the 2 represents February, I believe. So yeah, 1889. And then we look at February 2010, BWI 50 inches, and Dulles 46.1 inches. I don't recall in 2010 what DCA had relative to the 35.2, but this 1889 record still stands for DCA for Reagan. Snowfall extremes, there are your 3 major airports, Washington, Baltimore, and Dulles. 1 to 3 day totals. 1922, for instance, 28 inches over a 3-day period at DC. Looking at Baltimore, 29.2 in 2016. That was a big storm we had that lasted, I think it started around Friday around noon and went all the way like Sunday at 2 or 3 p.m. in Northern Virginia. But it was a real long duration period of snow. That Friday when it started, I worked a 6 a.m. to 6 p.m. shift to help out. I was actually off, but I saw how big this system was going to be. And the GFS model had this pegged 8 or 9 days out, I think it was. And then the Euro picked up on it, the Euro deterministic models. And then when those two kind of were in sync with each other 4 or 5 days out, that's when our office really started getting into panic mode. Like, we got to let people know this isn't going to be a 2-inch job. This is going to be a several inches to a foot or more. Here it comes. So we're trying to get the model's consensus without being biased to one particular one. So your long-range models may indicate this, just like the GFS model has a tendency to go crazy with hurricanes. Once we get into June, it seems like the computer model and the algorithms pick up, hey, it's June, beginning of hurricane season. Let's just throw 3 hurricanes right on the map right now. But then the next day, you look at the next day at the same time frame, the same model run, there's no hurricanes at all. It's just open waves. So it varies a lot with those long-term models. And, obviously we're always trying to perfect the long-term computer models, but in this case, with storm systems and nor'easters. The 2016 storm, I think the GFS 8-9 days out had something forming near Georgia, and that's where you want a coastal low. You want it to form near the Gulf of Mexico with high pressure over eastern Canada, and that's where everything starts coming together. So it's really interesting to look at long-term patterns to see what kind of setup we're looking at. Ingredients for winter storms. As I mentioned, in this case, the satellite imagery to the left, the white obviously is snow cover, and where it's brown and darker towards southeast Virginia, there's no snow cover. So this is a setup where you're going to have a warm front that pretty much snakes its way down the Appalachian chain and then up along the coast, indicating that the cold air is trapped east of the Appalachian Mountains and Blue Ridge, eastern Maryland, southern Maryland, northeast Virginia, down to toward Charlottesville, Virginia. So you get cold air trapped. You may have some overrunning precipitation. It could be snow, sleet, snow and sleet, and freezing rain. But once that warm front lifts north, depends on how fast the warm air can respond. Does it change over to rain briefly and then bring on the rain, snow, and then the heavy snow? So it depends on where the setup's going to be. In this case, the occluded low is over Wisconsin. If that ends up being, say, over Ohio and West Virginia during this time frame, that heavy snow band that you see on the backside in Wisconsin and Michigan would be over us. One of the studies done by Richard Grum with the Weather Service, and we pick up on his studies and theories as well with patterns, is when a coastal low develops somewhere near southeast Georgia, southern South Carolina, and tracks along the coast, if it takes a track between Norfolk, Virginia, and Cape Hatteras, and that window, if that low tracks in that direction in a northeasterly fashion toward eastern Long Island, that's a great setup. You just need the cold air in place, and you need some energy coming in on the backside to really tighten up that low. So that track is what we look for when we look at major winter storms. If it goes over Williamsburg, over Ocean City, we're probably looking at a couple inches of snow mixed with some sleet and freezing rain. So it all depends on the track, the cold air in place, the upper level energy that's going to fill in, and what's going to tighten up and what isn't. So this is the ingredients of the winter storm aspect. As I mentioned, the cold air, the moisture coming up from the south, and the lift. The lift is the front, or the low pressure system that's over Wisconsin. Sources of cold air: cold sinking air, high pressure air sinks. High pressure cold air, air flows around the high pressure clockwise, so it's going to come in from some colder areas or origins of central and eastern Canada. It's going to come in across New York, Pennsylvania, New England, eventually down the Appalachian chain. Cold air sinks. It can't go over the mountains, so you end up having some cold air damming. And cold air damming is that cold air trapped. You get some warm moisture flowing over top of it, then you get a mixture of snow, sleet, and freezing rain, or maybe just plain old snow. Cold air damming, as I mentioned, here's a map of how cold air damming looks. You can see the wind barbs pointing from the north. So the wind is coming out of the north and northeast in Virginia and North Carolina. Off the coast of North Carolina and Cape Hatteras, you can see the wind coming in from the southeast. The wind barb is pointing toward the southeast. So there's where your boundary is. So your stationary boundary, and then you've got the warm front going up over West Virginia and then all the way down into Georgia. So cold air in place, and it basically doesn't move over the mountains. It's cold and dense. And sources of moisture, we have all different kinds of moisture. Atlantic, Gulf of Mexico, even subtle moistures like the Potomac River, anything that can provide moisture to a system is going to be beneficial to a snowmaker. And basically we have a really good area and source for that, multiple areas. Sources of lift could be a warm front, mountain effect, or cold front. Warm front and cold front, pretty much self-explanatory. Mountain effect, like I said, cold air rushes in from the northeast. It can't go over the mountains. It's cold and dense. The air slightly above that, near the top of the mountain, might be slightly warmer, and you're not going to get the cold air to displace the warm air. The warm air is the one that's going to rise, so the cold air is stuck near the surface. So you get the cold air in place, and you get enough moisture and a system coming in from the west. That's where you're going to get your best setup. And as I mentioned, the best combination, coastal lows and nor'easters. Low center acts as a source of lift. There's the low sitting off the coast of Ocean City, the Delmarva. Wind barbs indicating the wind around it, wrapping around it. You got some cold air up in Canada. You can see the numbers, the top numbers are 1 degree, 4 degree, 8 degrees, cold air, and the wind is bringing that down. It's called cold air advection. So that wind, that air is coming down. wrapping around the storm system. A 992 low is pretty healthy. If you see something like a 984 or 980 in that same location, it's even better for a snow producer, especially inland areas, I-95 corridor and just west. Low center acts as a source of lift. The moisture comes in, wind circulating around the low, and there we go. We have a nice storm system. Classic nor'easter setup. Big area of high pressure in the top left graphic over centralized over, say, Cleveland and Pittsburgh. Cold dome of high pressure, cold air is in place. Down, still looking up the top left, the warm front over the Gulf of Mexico and the low over South Texas. Now, one thing to look at is that warm front that's across the Gulf of Mexico and from left to right, low pressure systems tend to follow the orientation of those warm fronts. That's where the pressure falls. That's where the greater pressure falls, is where that front is. So low, based on that top left map, if you didn't have this bottom one here, where's that low going from southeast Texas? It's going to go across the Gulf of Mexico. And as that warm front lifts north toward the Gulf Coast, then that low may also lift a little further north. So the track of the low is going to have to come from, say, the northwest Gulf of Mexico, across the Gulf coastal states, Georgia, South Carolina, and come up the coast. And therefore, as it comes up the coast, it's getting more moisture from the Atlantic, Gulf of Mexico, Potomac River, you name it. Cold air is already in place. And now the bottom right map, you have a secondary high building over the Hudson Bay. That's enforcing that cold air with that first high pressure. So now you're really pounding that cold air home, and you have your low pressure system forming off the coast. And as I mentioned, between Norfolk and Cape Hatteras, there's where your low is. So if it tracks in that general path northeastward, with the cold air in place, you're looking at a pretty good setup for seeing inland heavy snow. I-95 corridor west, say between I-95 and I-81, maybe a little bit further south and east of 95, close to the bay but not quite to the bay, is where your threshold's going to be the highest, or your gradient's going to be the greatest. You're going to have the heavier snow right there. And there's just a map pointing out what I just mentioned: high pressure over the eastern Ohio Valley, low pressure over Texas. Classic nor'easter, the path of the storm plays a major role in determining what type of precipitation we receive and how much. Lows sitting off of Norfolk. Obviously, we don't have the arrow the direction of the lows pointing, but that's pretty good. Sitting about 70 miles off the coast of Norfolk. You can see the coloration in the map detailed of what we're looking at here. Yes, there is some snow out in the Shenandoah Valley in Virginia and eastern West Virginia and the mountains of Maryland, but it's 3 to 6 inches. The heaviest snow, I-81 to I-95, is going to get hit really hard with this particular setup. The mixed precipitation probably starts mostly as snow. More moisture and more warmth comes in off the Chesapeake and the Atlantic. That's going to play a role in the dew point and the moisture available. So you're going to get a little bit of sleet, a little bit of a sleet issue. Sleet's going to downplay your snow amounts because it helps it compact. Snow and sleet combined is going to give you less accumulation than what it would be just plain snow. Throw in rain factor, like you see in Delmarva, out from Ocean City, Salisbury, Cambridge area. It's going to be all rain. So very tricky scenario, and see who gets what. But with the studies that were done with past meteorologists on tracks of the low and how strong they are, I-95 is nearly a sure bet of getting heavy accumulating snow should that low track between Norfolk and Cape Hatteras. Alberta Clipper is something you hear quite often. Here's a simple diagram of what it does. Low pressure forms near Alberta, Canada, or in that vicinity, and it tracks west-northwest to east-southeast across the northern plains, Great Lakes, Mid-Atlantic, and then out to sea. It's relatively a fast-moving low, and because it's fast-moving, you don't see heavy snow accumulations. But if there's enough energy with it, enough upper-level disturbances up around 25,000 feet fueling this low, and you get a nice, good moisture fetch ahead of the low system, say high pressure off the coast of the Carolinas bringing that warm, moist air from the south, it's going to really enhance the snow amount. So that's why, you typically 1-2 inches, maybe 3 in this area is common, but you get that 5 and 6 inch storm. If you look back at the track, look back at the energy support and also the moisture support, this pretty much has a good tight gradient in terms of how a lot more moisture, a lot more energy with it that caused that 5 to 6 inches versus just a simple 2 inch amount. So that's basically an Alberta Clipper. Winter hazards is what we forecast: basically heavy snow, ice, cold outbreaks, wind, and flooding. Yes, you can get flooding in the winter. It doesn't necessarily have to rain. Back in January of '96, we had a major storm system. I don't recall what we had in this area, in the metropolitan areas, but I was Yeah, I'm old. I was in college back then, community college out in Western Maryland. We had 36 inches of snow just on the mountain. Well, the next 2 days, snow melted. That 30 to 36 inches melted really fast. We had temperatures 55 to 62. And some of the small bridges there that have been around for decades just got wiped out from the floodwaters. All that runoff from the mountains, all that snow melt. Up near Cumberland, Maryland, they had a huge flood mess northwest of town. Water rose out of Wills Creek going into Jennings Run, Wills Creek. Some of these streams that go into the Potomac and near Cumberland, Maryland, they came up out of their banks really fast. All these dealerships there took a hit. So it was a pretty significant thing. So flooding, you don't necessarily always have to have rain. You can have the quick snow melt, warm temperatures fall, after a storm system, and that's the perfect setup for that. What is a blizzard? Winds of 35 miles per hour or more, visibility near zero for at least 3 consecutive hours. So if you remember those factors, that's your definition of a blizzard. So if you're looking on our website or you hear the TV meteorologist say National Weather Service has issued a blizzard warning for Howard County, Baltimore County, Montgomery, Prince George's County, we are seeing pretty much all of these, or a very good possibility of seeing all of these combined. And the blizzard of February 9th and 10th of 2010, that was an example. We launched a special weather balloon that day to get an idea what the profile looked like of the atmosphere, to see if we're going to see mixing or all snow. And launching that balloon was just crazy. I mean, having to try to get the instrument off the ground with the wind blowing consistently over 35 miles per hour. You have blowing snow, and it was still snowing. That was we did get it off with a train derailleur that allows the instrument to stay off the ground long enough, or it allows the balloon to lift without the instrument hitting the ground, and that was a tricky setup. But I've launched in a blizzard, and it's not easy compared to a day like today, where you have a little bit of a light breeze. But a blizzard, if you remember that's those are the 3 ingredients of a blizzard. I'm gonna see if this will play for me. This is supposed to be a short video of. Let me see. Maybe it's not going to play for me. See if I go back one window here. Oh, maybe this isn't the video. Oops. Want to see if what that. Oops. Thought I had to go through one more screen. Have the video going. Anyway, this is I'm trying to think. This was near DC, I believe. That was the video taking of this gentleman walking down the street toward the camera and then passing by. But as they pass by, you can see the wind blowing and it's snowing. Visibility is greatly reduced, but at one point, literally 10, 15 feet away, he just disappears. And visibility of near zero, that's pretty close to it. So basically, snow amount is not a factor in determining blizzard. It's going to be snowing, visibility near zero, because the snow is blowing 35 miles per hour. And you got to look for at least 3 consecutive hours. If we think it's going to be even close to 2, a little over 2, we're not going to chance it and not issue a blizzard warning. But if we have any positive indication, 80% possibility that all 3 of these are going to be met, we're going to issue a blizzard warning. So I don't know if we'll see one this year. It's a little bit too early to tell, but at least that's the question everybody's asking. Well, what is it, a blizzard warning or is it a nor'easter? And there's a difference. So in this case, that's the blizzard warning. What determines precipitation type? You're looking at basically a cross section of the atmosphere. Cold air aloft. All precipitation will fall as snow. It's going to be freezing or colder right where the precipitation originates, thousands of feet up. Depends on how thick that warm air is. Will it melt all the way or partially, and then it falls into colder air? So the warm air wedge in the middle between the 2 cold air masses, how thick that warm air is crucial to determine if it's all snow. In this case, warm air is not affecting it. If it's a wide wedge of warm air, say to the to the left, as you can see, it's a wide wedge of warm air. It's going to fall in the form of rain. You could even see the snow, sleet, and freezing rain combination when you're looking at it in the sense of somewhere in the middle of the screen. Snow, as you can see off to the right, where it's all below freezing. But then as that warm air wedge comes in, and that's what I mentioned, if you remember that cold front, that is part of the system, developing system, cold air damming, cold air trapped in the mountains. So that warm front lifts north. That warm front is going to be the source of the warm air. So how thick is that warm air behind that warm front is going to determine what you're going to see in terms of how much snow, sleet, freezing rain, and rain. A little diagram here to help you with the colder air. You can see the snow falls, snow melts once it gets above 32 degrees as it falls. It's warmer near the ground. In this case, you're looking at all rain. And this is all snow. Temperatures remain below 32 degrees in all layers of the atmosphere from the cloud to the ground. And then it's colder aloft. Once again, snow. Snow melts in a warmer layer, but it quickly freezes again, and that's when you're going to get the sleet. So it's a really tricky situation, but looking at a SKU-T diagram that we use at the office to determine how thick that warm layer is, it determines whether our forecast is all snow, or if we're going to go, say, sleet and rain, maybe changing back over to snow if that cold air gets reinforced behind that storm system. And then here's your freezing rain aspect. Cold, starts as snow, melts, continues to melt, and then all of a sudden, right before it hits the ground, it happens to be near freezing or below freezing, and the surfaces, or those guardrails, sidewalks, concrete sidewalks, structures, vehicles, the temperature of those objects are at or below freezing. You have your freezing rain aspect. So the thickness of that warm air determines whether it's going to be snow, sleet, freezing rain, or rain. And there's a diagram of them all together if you want to take a snapshot of those and kind of get an idea what we look at. Well, when you see the forecast and it says snow changing over to rain, ending as snow and sleet or something like that, this is kind of the setup you look at as a cross-section diagram of each of the four winter weather precipitation types. Mixed precipitation profile, and we go to the heavy snow. Heavy snow, as I mentioned, the setup for the nor'easter, the low pressure system, Norfolk, Cape Hatteras area, the track, the cold air in place, the moisture coming up from the south. Obviously, heavy snow disrupts the transportation, closes businesses and schools, collapses roofs, as well as down trees and power lines, and it's a pretty significant cost when you talk about snow removal. Ice, power, and communication lines come down, traffic accidents, pedestrian falls, heavy weight can bring down trees. The upper right, the Mixing Bowl, Springfield, Virginia scenario back in 2008, where all those overpasses in the Springfield, Virginia area, most of them, if not all of them, were iced at some point. And all it takes is, all you have to do is a few miles per hour in your vehicle and you're not going to be able to stop. Ice, four-wheel drive doesn't really go on ice, and you have no control of it. So that's why if you hear about an ice warning or ice accumulations of 1/10 of an inch, expect slippery bridges and overpasses. If you don't have to go out, it's best to play it safe, because you may be able to maneuver yourself off to the side of the road where there's some snow and sleet that was just brushed off the road there with ice on the road. You may be able to get enough traction to get off the road or get home, but somebody else doesn't know. And when they go to stop, and you get hit, and that's, the best thing to do is just, when you have an ice, a major snowstorm, anything like that, the best thing to do is to stay home and wait it out. Cold air outbreaks. This is the coldest temperatures of the 20th centuries that we found on record, January 13th and 14th, 1912. Cold air outbreaks, the exposure, you're worried about frostbite, you're worried about hypothermia, automobile problems, pipes bursting, drip your pipes. If you hear of a forecast we're looking at consistent highs in the lower to mid 20s, lows in the forecast, single digits or negative single digits for a period of 2, 3, 4, 5 days. Play it safe, find your outside pipes and drip the faucets. The best thing to do, or add insulation around it. Best thing to tell you, because a lot of homes now, condominiums, apartments, do have bathrooms, but their pipes are really close to the exterior wall. And when you get temperatures, we're not going to see temperatures like this, I don't think. We've had negative single and teens below zero for lows and teens for highs in some cold recent cold that I can think of in the last 10 years. But either way, to play it safe, the bursting of pipes is just a pain. And I've had some friends that have had that happen, and it's not fun. So drip your pipes. It's not going to hurt anything. Power shortages, obviously, power outages, power lines falling. That's another thing when you talk about cold air outbreaks. Most recent sub-zero days in DC, -4, 1994. Baltimore, -1. Dulles, -2. So there's some cold air, and yes, we do get them, and depending on the climate season, El Nino, La Nina, short-term patterns. Yes. I'm sorry? Right. Yes. This is just raw temperature. Yeah. The -4, -1, -2. These are raw temperatures. Wind chills. I don't think I have those on here, but yeah, we've had some winters where I've been in the office and we've had 3 consecutive days of negative single digits or negative teens for lows, and like 5 consecutive days of teens and 20s. And it turns out at that particular time, I've noticed the pipes, like you go to turn the water on and nothing's working. And you get to thinking, did I drip my pipes? It's one of those things. But the question was, yes, these are raw temperatures. Wind chills can be much more brutal, 20 to 30 below zero. But these are just raw temperatures. Good question. And wind, blizzards, blowing and drifting snow, heavy surf, beach erosion, coastal flooding, trees and utility lines, and wind chill. All these factors. So at the office, when we're super busy, winter and summer, winter season, we're not just looking at snow and ice and rain, but we also have to deal with, well, okay, we had 10 inches of snow and it's a beautiful sunny day, but it's 25 degrees. If the wind picks up, maybe a dry front moves through, is that snow going to blow and drift? Is it the powdery snow or is it the wet snow? All these factors we have to play into a role where how do we warn the public, how do we warn transportation what to expect over the next couple of days with whatever we have. Winter flooding, as I mentioned, flooding doesn't have to deal with just rain. You can see some snow melt. There's some ice jams there that have happened on the Potomac River, among other places. They play a huge role or a game with our river gauges when we're trying to see legitimate river flooding from snowmelt, and all of a sudden these ice jams come rushing in and they really mess up our numbers. But our hydrologist is on guard with that all the time with what's going on, and does it look like a scenario for that location. Coastal flooding, that's a year-round thing. You get the right fetch, the right air off the water, off the Chesapeake or the Potomac. You can look at coastal flooding issues. Sudden snow melts, as I mentioned, back in '96 when all that snow melted in western Maryland, it caused some flooding issues. I'll take a little short break here. I think a lot of this stuff we're going to see a lot more graphs and statistics with winter. But there may be some repetitive stuff in here, but it's because we want you to know what we expect from you in terms of reports. But we have a lot more to cover, so take a 10-minute break and stretch and go to the restroom or whatever, and come back here in 10 minutes and we'll get started. There's a lot more information, so I just want to let that out there. Okay, I think it's most everybody back, so we'll get started with the second half and try to get as close to 8 as we can. There's a lot of information, a lot of statistics and diagrams, but I'll try to do the quick hitting aspects. And once again, you have other questions at the end of the presentation, I'll be glad to answer those. And I'll have some contacts up here. I can give you my contact at the end as well, my email address, but our SkyWarn, or our warning coordination meteorologist, as well as our SkyWarn program leader, Chris and Jeremy, they can be contacts as well for additional questions about this course or information that you might have. So we'll go ahead and get started. One thing to mention that was brought up to me about snowboards that break makes sense, physical sense. I don't think I've taught a class or been to a class where I've heard other instructors say this, but if you have a snowboard in the garage, you do this annually, and it's great. You probably already know this, but say you have a snowboard in the basement or in your house, and the temperature inside 77 or 68, or your garage is 50. You're expecting snow. You want that snowboard not just to be white and marked and staked and everything, but you want to get the ambient temperature of the atmosphere before it snows, because as the snow starts falling, every flake counts, and you don't want that snowboard going out to do measurements to be at like 58 degrees when the air temperature prior to the snow is 34, dropping to 32. You know, you're going to get those first couple flakes melting. How much is going to melt? That's physically to be calculated, but you don't want to lose the accurate accumulation and measurement. So get that snowboard out there. When you hear about snow in the forecast, even if it's a 30% chance of the first snow, that might be a good indication to find your location, stake it, make it level, make it white, mark it, and get it ready. And you know, really don't have to touch it until it actually starts snowing, but get it to that ambient temperature so that way when the snow hits the board at first, it's not going to melt right away. So one thing to bring up there. Other than that, I think we'll go ahead and get started with the rest of this. National Weather Service products and services. I gave a gentleman here the website address here, weather.gov/LWX, weather.gov/Baltimore, weather.gov/Washington. Either of those three will get you to our main page here. You'll see a map in the middle with a key off to the right telling you what hazards and advisories there are. In this case, this is a snapshot of our winter weather page. In this case, looking at this map with the painted basically northwestern Howard County, Montgomery County, Carroll County, and west. In this case, it's a winter weather advisory out. You can see under the current hazards, the winter weather page, you can click on that link to go to that. This is our hazardous weather outlook. It tells you what to expect over the next 7 days. Winter-wise, it actually just tells you in general any hazards that we may have out there. Even if it doesn't pertain to you or to your interest, go to this link, HWO, to this page as much as possible to see what's going on. So winter weather outlook is issued when a winter weather event has a potential to threaten life and property in an extended period of time in the forecast, provides information to users that need considerable lead time to prepare for an event. Hazardous weather outlook. Winter storm watch is an example of a hazardous weather outlook. So winter weather outlook gives you the idea what we're thinking of. Hazardous weather outlook, check that for hazards, winter storm watch, blizzards, winter weather advisories, cold air cold outbreaks, anything like that. So in this case, like a winter storm watch would follow suit on that. Winter storm watch, potential for hazardous weather in the next 48 hours. Winter storm warning, it's imminent or occurring. So if you hear of a winter storm warning, we're looking at that eventually occurring at any second, not any second, and very shortly, and not necessarily within the next 48 hours, but very soon. So keep tuned to the radio, our forecast, go to the website, give us a call. Life-threatening conditions, damage to property, you know, pretty much is a good indication that what a winter storm warning packs as a punch. One amount you might see if you go to a website, our website, and find your location on that map, and you click on it and it says winter storm warning. If you click on the link, it says winter storm warning. It'll give you a description. Snow beginning after such and such a time, expecting to accumulate 5 inches or more. Well, winter storm warning definition by our standards in terms of numbers is 5 inches or more. We're not saying it's going to be 5 inches. We're not saying it's going to be 10 inches, but a warning means you're going to see 5 inches or more, so be ready for if you can handle that 5 inches, whether it's snowing or whether it's snow plowing, shoveling, salting, whatever it is. Now, winter weather advisory is also crucial. It's an advisory, it's imminent and it's occurring. It's a significant inconvenience. It's not as powerful wording-wise and also snow-wise as a winter storm warning, but a winter weather advisory can definitely cause havoc. With the travel and the transportation and the traffic around here, as today was just a light breeze. It wasn't as hot as it was yesterday. But if we had a winter weather advisory and you're looking at an inch or two at rush hour, it's just a standstill. So we've seen that on television, on the news, at our office. When you look at a traffic pattern, it's like standstill. Like 1 inch of snow in the D.C., Baltimore area, metro corridor. Some people can drive in, some people can't, and it's just one of those things where we have to try to get a word out as fast as possible. Hey, even though you're only looking at an inch or maybe 2, it's going to be enough to cause problems. So just stay home, or delay yourself to work, or delay yourself to home. Hazardous weather outlook on potential for hazardous weather through day 7. This is an example. It's issued daily between 5 and 6 a.m. and again around 11 a.m. It's updated as needed. This includes potential for a SkyWarn activation. So in this sense, in this HWO or hazardous weather outlook, a winter storm warning is in effect and gives you a description of where. It also has an indication of a wind chill advisory, so we do take that into account when you're talking about the wind, the temperatures. And then also as you look through days 2 through 7, we give you a little bit of a heads up. Hey, wind chill advisories are possible for late Friday night into Saturday morning, and this is actually Thursday afternoon forecast. So we want to give you a heads up. Hey, just be ready for these hazards. More details, as I mentioned, in the middle of their day 1, it gives you great details, watches, warnings, and timing. Days 2 through 7 are closer to the bottom. And then, of course, the SkyWarn activation in the bottom there. A winter storm watch. A winter storm watch is issued. Now, winter storm watch is issued when 5 inches of snow is expected within a 12-hour period. Ice accumulation of an inch or more, or well, not an inch or more, a quarter of an inch or more, damaging combination of snow and or ice with some high winds within a 12-hour period. And typically it's issued within 24 to 48 hours in advance of the event. So winter storm watch, winter storm warning. Watch means possibilities are there, the ingredients are coming together. The storm system may be taking shape over South Carolina, but we're uncertain on the exact track yet. When you hear warning, we're certain something is going to happen. It's going to affect property. It's going to affect your life. Heads up, take precaution, and it's ready. So when you hear the winter storm watch, and since it's issued 24 to 48 hours in advance, that's probably the time to act in terms of getting prepared, whether it's ice melt, snow shovels, an extra heater, a generator, thinking about that when you hear the watch. Now, you may not necessarily need it, because if that watch doesn't go to a warning, maybe it just becomes an advisory, which is like an inch or 2 of snow. But winter storm watch means the potential is there. And when you're dealing with coastal storm systems and nor'easters, that's something you probably don't want to gamble with, just like a landfall hurricane or a tornado outbreak. You just don't want to take that chance. Just be ready. What kind of information does a watch include? Keyword potential, watch, and potential. You see watch up there 3 times in yellow, and potential is circled. Potential is there, whether it's the moisture, the lift, or the possibilities of a wintry mix or just heavy snow. Winter storm warning. A winter storm warning issued when the following has a high probability of occurring. Once again, 5 inches of snow or more in 12 hours, or 7 or more inches in 24-hour period. A life-threatening or damaging combination of snow and ice accumulation with high winds, and a combination of damaging sleet and high winds. The key word, expected or occurring warning. So potential is watch, expected or occurring is warning. Winter weather advisory. Winter weather advisory, it's a lesser of a winter storm warning, but it still has a great impact. When a combination of snow, sleet, and ice will cause a significant inconvenience, but not serious enough for a warning. Average of 2 inches of snow, sleet expected to fall within a 12-hour period, or less than 7 inches in a 24-hour period. Any accumulation of ice, whether it's a trace, whether it's a hundredths of an inch, 1/16 of an inch, anything like that, any accumulation will justify an advisory from us. Usually issued within 12 hours of that time frame. Winter weather advisory contains the same information as a winter storm warning. It tells you the time of what we're looking at in terms of day and duration, the precipitation type, the accumulation and of what, the timing, temperatures, and winds as well that could affect whether it's wind chills or wind-blown snow, whatever it may be. The details are there and will be in the forecast. Now, one thing we've come up with in the last year, the National Weather Service has a new we use the same tool as if we issued a severe thunderstorm warning, a tornado warning, a flood warning. That's a program we have at the office called WarnGen. So if you're watching, if there's storms erupting at your house and you're watching TV and a red screen goes across the TV and it says tornado warning for whatever, that's initiated from us. We draw the polygon up where we think the best chance of that tornado tracking. Hit the send button, and it goes out to you instantaneously via NOAA Weather Radio, television, TV meteorologist, NOAA Weather Radios. It goes out instantaneously. So we realize that snow squalls in our area, especially in the past couple of years, I-81 has been affected like more than 2 or 3 times between Hagerstown and Martinsburg. Speed limits are 70 miles an hour through West Virginia. Wind direction and snow falling at the same time. When you put those 2 aspects together, and it sets up the perfect scenario for a snow squall. Snow squalls are basically 10-mile visibility and sunny and a few puffy clouds, and all of a sudden, boom, total whiteout, and you're doing 70 miles an hour. That's a snow squall. So especially if you're looking at a radar, if you're driving and your friend or your family members on the phone looking at some snow, and it happens to be a line of a snow band coming across the interstate ahead of you, you're going to see this. You're just going to be like perfect driving conditions, 70 miles an hour, and then boom, whiteout, and then accidents, pile-ups and stuff like that. So National Weather Service made the directive that the offices now that are prone to snow squall warnings issue a warning in the same program that we issue a tornado warning, severe thunderstorm warning, to give people a heads up. So obviously there's a lot of factors: wind direction, wind speed, past storm systems, what direction is the air coming from, how cold is it, and so all these factors come into play. So if we're looking at radar, and radar is quiet right now, we're looking for these little tiny thin little bands on radar that might look like geese or bees or something like that radar can pick up, and ends up being snow squall, and it tracks across a particular area. So snow squalls basically are intense but limited duration periods of moderate to heavy snow bursts accompanied by gusty winds, reduced visibility, whiteout conditions. Rapidly falling temperatures in conjunction with the snow can cause dangerous impacts to surface transportation where the roads freeze up very quickly. Typically they last 30 to 60 minutes. Sub-freezing road temperatures, high-speed highways and interstates. I-81 is an example. I-70 in some parts probably get those too. But when we get into the heart of winter and we get consistent cold patterns and cold storm systems, we got to watch out for those on radar and issue those. And that's what could happen when a snow squall hits, especially on a highway that you're doing highway speed. There's no safe place on a highway when a snow squall approaches. I mean, it goes complete whiteout, and you may be able to have that traction and audacity to pull off the road and quickly stop, but you don't know what's coming behind you. If they do the same thing, if they don't do the same thing, tractor trailer jackknifes, just a bad scenario where you just never know. Think about what the temperature is outside. Is there snow already on the road that's been mostly cleared, but there's still some patches? It's just snow squalls. We at the Weather Service to try to give everybody a heads up as fast as possible. And we work with the Department of Transportation to get these signs lit up along the highways where we issue a snow squall warning. Then you probably will see, hazardous weather ahead, so reduce your speed. I don't know if you're going to actually see snow squall, but you'll see hazardous weather, reduce speed ahead. Yes, sir.
Will that also be sent to cell phones the same way tornado warning would be sent to cell phones?
I think it does. I'm going to have to ask Chris Strong on that, our warning coordination meteorologist. He's the one that passed on that word from National Weather Service headquarters that we were doing this, and I can't remember for sure if that's the answer, if it does go like a tornado warning, but if you have your phone set on any kind of alert, it should come across there as a beep beep beep, but I don't know for sure, but I know when we issue it and we warn on it, it's almost like issuing a tornado warning. We want to try to give everybody a heads up. Even if it doesn't happen, we know enough about snow squalls to where any positive 60, 70, 80% possibility of it happening, send it and then let everybody know. Because that one time that you have a slight hesitation on it and we don't issue the warning, then something like that happens. But I'm not sure if it's going to chime in your phone or warn your phone. But I have to ask him on that. If you want to, you can get my email address or Chris. I put Chris's up here. You can say you attended this class and ask him, does it warn on NOAA weather radio, cell phones, and stuff like that? Because I don't 100% know the answer, but I know that's something that we just came up with last winter that we went through training on with the snow squalls. Yes.
I think it does.
You think it does?
One of those warnings near Hagerstown.
Oh, you did?
Recently, yeah.
On your cell phone?
Yep.
Okay, so gentleman up here say he did get a warning on his cell phone, so that's good if it does. My gut feeling said it should, and it does, because it's from the same program that we issue tornado warnings, but I wasn't sure. So that's a good question. How much trouble can 1/10 of an inch of ice cause? 1/10 of an inch, think about cold rain, freezing rain. You see it glazing on your concrete sidewalks. Tree branches are starting to glisten. Boom. Just ask the people that were unfortunate enough to be in Springfield, Virginia, February 2008, the Mixing Bowl, where all those elevated passes iced up, most of them, if not all of them. And so people were stuck on that for hours, some accidents, nowhere to go. It's just one of those unfortunate situations where in the wintertime, if the road looks wet, it's probably icy. Even if the temperatures say 37, 38 degrees on your car, and you're positive it's above freezing. You just don't know how much cold air went underneath those underpasses and bridges. So best thing to do is when you're driving around wet roadways, secondary roads, interstates, if it looks wet, it's probably icy. Treat it as if it was, and that way you'll be prepared as much as possible. At least you will. 50 ramps and overpasses, $676 million in damage, 430,000 vehicles a day. This is one of the largest interchanges, and that's what happened where just a 1/10 of an inch of ice caused an ice up. 15 plus car accidents, including 8-car pileup. People sat on ramps for 7 to 8 hours, including a former Virginia governor. Yeah, I know. That was before I joined the weather service. I'm sure somebody said something to my boss. I didn't hear that conversation, but just a couple notes. An ice storm warning is issued when ice accumulations of 1/4 of an inch or more are expected. We don't issue those a lot, but when we do, we usually get enough ice to cause problems. It may not be 1/4 of an inch, but we get enough ice where you hear about accidents everywhere in the region. The DC area, particularly since we're closer to DC. Not issued for a mixture of snow, sleet, and ice. A freezing rain advisory is issued when freezing rain will cause a significant inconvenience, but not serious enough for a warning. And a blizzard warning is issued. we used to have a blizzard watch, but that was eliminated because the word watch and warning, people were hearing blizzard watch and nothing, they weren't listening to, potential was there, but we don't want them to neglect or to be just nullify the blizzard watch. We want them to take heed or take warning, take caution. So we've eliminated blizzard watch, but we do have the blizzard warning. So any one of these three that you see, prepare for some kind of travel hiccups and slow travel and everything. If you don't have to go out, the best thing is not to go out in that sense. And we've gotten blizzards before. As a matter of fact, in January 2016, we had enough snow and enough wind that I said I worked that 12-hour shift when the snow started, and then I was off the rest of the weekend. It snowed all weekend. I found out when I went back to work on that Monday or Tuesday that everyone at the office who worked after I had left, and me and another forecaster had left, it got so bad at the office that even the simple plows that we hire and under contract to plow our driveway and our property to get to and from the office, the National Guard had to come out. And the government, National Weather Service, we are required to be there 24/7 no matter what. So the ones who worked the second half or the middle and the latter half of that blizzard ended up getting rides with the National Guard in Humvees to and from their house or hotel, depending on what they had, because we were required to be there. Now, a few of the forecasters spent the night. We have accommodations there. Some went to a nearby hotel. So we get these nasty storms. We're always there. So when you call us in with reports, don't think we're not there. It's just too bad out. That was one of the scenarios where it's very interesting that I found out some of my colleagues were, you got to ride a Humvee with the National Guard? Oh my gosh. It's both like in awe and also, what in the world? What are we doing? So that's that. Just a few more notes on advisories. Advisories can be issued for sub-criteria events, first snowfall of the season, whether it be November, late October. Give everybody a heads up. Snow showers and squalls produce locally heavier snowfall. If 1 inch of snow is expected to impact the metro areas, especially during those 5-hour windows of rush hour period, to give everybody a heads up of what to expect and when. Winter probabilistic graphics. These are graphics you can see on our webpage. If you go to our webpage, /LWX/Washington/Baltimore, and you go to the winter page, the winter icon, there's a snow amount potential. The big map there on the left, it will be what we're forecasting. This is what our forecast is. The absolute worst case scenario is the upper right. And what you're likely going to see, almost no questions asked, is going to be the bottom right. So this big window, the big one, the amounts in there are more likely going to be between the top one and the bottom one, because the big one is our forecast. The absolute worst case scenario is upper right, and then of course what you're likely going to see is that. So it's think of it as a goalpost, and that's what we try to warn emergency managers and spotters of what to expect. So if you see these maps and all of a sudden you see like 18, 24 inches in the upper right, that's the worst case scenario at that particular time with that particular model run. And the one that we're forecasting is the big one. So that's when you want to look at a quick hitter. If you want to get an idea what we're thinking, you go right to that big map and it stands out to you. Oh, the Weather Service is saying I'm going to get 5 inches. but the worst case scenario might be 24, and you're definitely going to see 1 inch or something like that. It's going to be in the middle. Winter probabilistic graphics, we also give you a probability of getting greater than 1/10 of an inch of snow, greater than or equal to 1 inch of snow, 2 inches, 4 inches, 6, all the way up to 18, gives you a probability or a chance that you're going to see those amounts. So you can look at each one of those maps in general. If you see an 80% chance of 8 inches or more and a 38% chance of 12 inches or more, well, I'm leaning toward that 8 inch, maybe a little less, maybe a little more. The higher probabilities, the better chance you're going to getting that. And obviously, if you're getting 80% chance in our graphics at 8 inches, all the ones to the left of there, 6 inches all the way down the trace, are going to be greater than 80% or the same. So, winter probabilistic graphics. Winter storm threat graphics that we've designed to try to focus on forecasting beyond the confidence of days 1 and 2. We want to look at days 3 through 7 in the future. And before, we had 2 sections. Now we've got 3, because you can break this region down, or our region that we forecast for, in so many different ways. We've split counties to try to get a most accurate representation of the atmosphere and storm systems. So we have the far eastern one to represent the major metropolitan areas up and down the I-95 corridor, give or take east and west, the heavier populated areas, the heavily traveled areas, and then in the middle, more rural, some cities, Blue Ridge Mountains in the middle, busy interstates 81 and 70, and then in the far west you have your higher terrain, your higher elevation snow. So we broke it down into those regions based on directives and policies to try to better represent what a storm system could do. There's an example. In this case, we have them color-coded. The orange to the left, you can see we have a check mark, Allegheny front. We're thinking that it's going to be a middle potential impact and a middle confidence. So the confidence is going up the y-axis, and the potential impact is at the x-axis. So hence, we think that the Potomac Highlands out west are going to be affected greatly in this sense, kind of in the middle in terms of confidence and potential impact, and then a little lesser toward the Piedmont and the central areas, and then I-95 and east, no significant winter storms expected. So we color code it that way. Now you can get a purple in the west, and maybe a red in the central and the eastern zones, or maybe red, orange, and yellow. And there's going back to this thing, you can see down at the bottom of the definitions of what you're looking at. If you're looking at a red or an orange color in your area, what kind of impact, what kind of potential impact of a winter storm, and what that means. So we try to color code it, and it's mostly a very good representation, not just to the public, emergency managers, as well as Department of Transportation, to get an idea what our thoughts are and how bad it's going to be with the storm system. What do the colors mean? There's a little bit bigger picture if you want to take a snapshot of that. Definitions of what they high, moderate, enhanced, slight, and none. Those are the threats, green, yellow, orange, red, and purple. So we're pretty much looking at the worst case scenarios is the top is the high, and of course the very little precipitation, or it may or may not happen, is your green. So try to give you an idea on how bad it could be in this sense. High, enhanced. NWS products and services, here you go, Climate Prediction Center, cpc.noaa.gov. Beyond 7 days, we forecast out to 7 days at our office, but Climate Prediction Center looks at things beyond that, 8 to 14 days, 6 to 10, monthly, seasonal. So, to get an idea, a few of you at the break, I mentioned about how the winter is going to be, what it's going to look like November, December, January, February. You may not want to start with us. You can start with us and look what we have out through day 7, but if you want to see what it is, say days 8 through 14, check out CPC's site, because maybe our forecast is like, oh, beautiful, temperatures 10 degrees above normal, and then you go to Climate Prediction Center on days 8 through 14, and it's showing above normal temperatures. And like in this case, Colorado and New Mexico have the better signifier of having above normal temperatures, and that may carry on for our region as well. So Climate Prediction Center is more of your extended forecast, and we try to break it down into all the details through days 1 through 7. Temperatures 8 through 14 day outlook. This is an example of November 18th to the 24th in 2016. Above normal temperatures for the Great Lakes and Ohio Valley, color coded like so. Obviously, the better indicator is over the Great Lakes versus, say, the Rocky Mountains. Precipitation, 8 through 14 day outlook, below normal, as you can see along the East Coast. There's a signifier of above normal precipitation in the Great Plains and the upper Midwest. Temperature, 30-day outlook. This is also produced by the the Climate Prediction Center. This was made on October 31st, 2016, 30 days out. So what you're looking at is a map of the U.S. and what the Climate Prediction Center thinks is going to represent the temperatures in the month of November. So 30 days out, they're looking at above normal temperatures in the central part of the country, and then lesser as you get further out. Florida, probably near normal, equal chances of being above or below. Precipitation, here's another one for November of that same year, November 2016. Below normal chances or below normal precipitation possibility in the lower Mississippi Valley and Tennessee Valley, also below in the northern plains, above in West Texas and southeast New Mexico. A little bit about El Nino and La Nina. Yes, they are opposite. A little bit more of a definition of El Nino. We're looking at water temperatures out in the Pacific Ocean. That map, elongated map, is the Pacific Ocean. When you look at it from the west coast of Mexico, and here's South America, and then over there is Indonesia, South Korea, Australia. So you're looking at the large Pacific Ocean, and El Nino basically is warmer than normal December temperatures, water temperatures in the Pacific Basin, normal or below normal January, February, and March. So warmer than normal December, normal or below normal January, February, March. Well, you think January, February, March is cold anyway, but El Nino kind of enhances that possibility of increasing the strength of the southern or subtropical jet stream, which in turn would increase our risk for nor'easters, because you want those storm systems to develop along the Gulf Coast and move up the East Coast, up toward the Carolinas, up toward Norfolk and Hatteras. In order to get those lows to track like that, you need that southern branch subtropical jet stream to go across parts of northern Mexico, Gulf of Mexico, maybe southeast Texas, work its way across northern Florida and then up. You get a southern branch, an active branch like that. That's going to bring your low pressure systems in that direction, and all it takes is some cold air in the surface and upper levels to come in on the north side of that, and there you have your setup. So cold air will determine if this is snow or rain, and that will depend on that polar jet. So you can have a polar jet and a subtropical jet, and that obviously indicates lays the tracks for the storm systems and also the cold air in this case. El Nino winters at DC, December, January, February, average temperatures. The red indicates El Nino winters above normal. The blue indicates El Nino's winters below normal. The bottom x-axis, all El Ninos, gives you an idea of what the average temperatures are. Now they're broken down into weak, moderate, and strong El Ninos, just like La Nina is weak, moderate, and strong, that you'll see probably here shortly on my slides. But whether it's weak, strong, or moderate, I think for a good potential for nor'easter winter season, it's going to be moderate or strong El Nino. It could be weak, and all that might mean is above normal temperatures, slightly above normal precipitation, and then just one storm gets going. But a strong or moderate El Nino could mean multiple storms, different tracks. One could hit Baltimore really hard. One could hit DC really hard and leave Baltimore dry and cold. So it varies, and it's really tough to take the long-term patterns of El Nino, La Nina, and really break it down detail-wise into a forecast out through 7 days. Here's El Nino winters at DC. Precipitation-wise, you can see above and below, similar diagrams here. So you're looking at above normal precipitation on a strong El Nino winter. You increase that moisture, increase the amount of precipitation, you're probably going to have higher significant snowfall amounts with the El Nino situation. BWI, similar, you're going to have those above normal temperatures for the most part. Doesn't necessarily mean it won't snow. 36.6 degrees is above freezing, but it can snow depending on how fast the precipitation falls and how deep that warm layer is. If it's above freezing, it could still snow. Precipitation-wise, still above normal precipitation. Could that mean increased moisture into that storm system that develops and causes a nor'easter, brings that nor'easter home for us? El Nino winters tend to be bad for the most part, where we get above normal snowfall. We get days where it's really wet and not snowing, but then all of a sudden it takes that one setup of really cold air in place, and then a storm system coming up from the east or from the south, and then you get your storm system. El Nino winters, snowfall averages. The moderate El Nino winters in DC tend to favor more higher snowfall amounts, but like I said, moderate or strong El Nino winters, no matter where you're at, Baltimore, Washington, Charlottesville, Winchester, Hagerstown, think of it as moderate or strong El Nino. There's a potential for a couple of storm systems to bring that snowstorm home, but it could also mean just an icy, wintry mixed mess of snow, sleet, freezing rain with one system, and then that moves on, but then at the tail end of that, another one forms. So it's a really complex scenario to have when you have El Nino winters. But these are broken down into graphics and statistics. So your moderate El Ninos tend to favor more, especially as you can see these years in the last 66 years. Moderate El Nino even does better in terms of precipitation and colder temperatures than your strong El Nino. La Nina, milder winters usually relates to that. So looking at the Pacific Ocean basin again, as you can see that blue along the equator, that's indicating colder than normal water temperatures in the Pacific. So colder than normal water temperatures in the Pacific, decreased risk of Arctic outbreaks. It doesn't, pretty much milder winter and drier winter. So it's almost if you're a snow lover or a snow and ice lover and you want that one or two big storms, you want to listen for that. Where's that El Nino at? Is it? And then ask yourself or find out, is it a moderate, is it a strong El Nino, to get even somewhat excited. But even then, we've had some strong El Ninos in the last 6 decades, 2 or 3 of them. I think one of our forecasters had said 2 or 3 that gave us below normal snowfall, and people were like, well, that puts the kibosh on the whole El Nino thing. But it happens, and not every El Nino is the same. So it depends on climate change, it depends on the weather pattern. That subtropical jet in an El Nino pattern in the south and in a polar jet dipping down, that's going to give you a possibility of some snow or heavier snow. La Nina winters, average temperatures below normal. A strong La Nina, you're going to have above normal temperatures a lot more than you'll have below normal temperatures in a strong one. Moderate seems to be the low end. When you look at all El Ninos, weak, moderate, and strong, moderate tends to be the lesser, where it stays colder. So if you hear of a strong El Nino or a moderate La Nina, I kind of equate those almost similar to a similar potential of seeing a nasty nor'easter storm that's going to give us a lot of snowfall in this area. Precipitation, DC area, once again, moderate La Nina, winds out on the precipitation, 8.47 inches. For the most part, moderate rules in that sense in terms of the amount of precipitation possibility with a winter storm and storm system. And this is in the months, once again, December, January, and February. December, January, February, average temperatures, La Nina winters. We're looking at strong and weak. Average temperatures, you don't really have that indication or that signification of having a big storm system with La Nina when you're looking at temperatures alone. Temperatures and precipitation may have some agreement, colder than normal temperatures in the La Nina season, above normal precipitation in the La Nina season. Both of those factors combined, or one stronger than the other, could relate to a pretty nice, nasty storm, a nor'easter storm. Moderate La Nina, once again, precipitation-wise, winds out as well in Baltimore. Strong, not so much, but really the numbers, they're very close. As you can see, 9.06, 9.19, 9.26. They're very close, but statistics over the 66-year period, these are the graphs that we've come up with in terms of the research. Total snowfall, La Nina winters, snowfall amounts, moderate La Nina, winds on this one, 4 to 6 above. 4 of the 6 above, 24.9 inches. As you can see, the rest are below that, below average for those winters. Snowfall, moderate La Nina winds out again. Moderate La Nina winds out on that. A case study, February 13th, 2014. That was, I think I remember that one. I was working a 5 a.m. shift that day, and I'm trying to drive in at 4 a.m. with 5 inches of snow, and it's really snowing hard. Yeah, I think that's a setup. High pressure over New England, cold air in place. I know you really can't see the small numbers on here, but temperatures are in the 20s. Dew points, a measure of moisture in the air, they're in the single digits. The temperature and dew points at the surface are close together or are actually the same. You're looking at either precipitation, fog, possibly dense fog. some kind of stratus clouds when they're the same. In this case, you have cold air in place, temperatures in the 20s, dew points in the single digits, so you have some room to play with. When that temperature comes down with any cold air reinforcement, or the dew points come up with any moisture off the water, when you get those close together, you're going to have that atmosphere saturated enough to where whatever is going to fall, it's going to fall hard. In this sense, with that storm system, high pressure over New England's keeping the cold air in place, reinforcing high pressure over Minnesota, North Dakota with temperatures in minus teens. And then you have the low pressure over the Florida Panhandle. And as I mentioned, you get those coastal lows, Gulf Coast. Where is it going to go? Well, there's a little bit of an indication of a warm front near Tallahassee, Panama City area. That seems like it's going to track across northern Florida. From there, where's it going to go? This is a trough of low pressure, another indication of pressure falls. So as this low tracks across Florida, up the coast, cold air in place, and then you have your setup. And I think this was 2 days before the actual event hit us hard. And there it goes. It's coming up the coast. Carolinas, a double barrel low, North Carolina and southeast Georgia. High pressure Nova Scotia, but cold air still is in place. And as you can see from this map, watch that low over southeast North Carolina from this map to this one, right between Norfolk and Cape Hatteras, the surface low. And as it does so, cold air is already in place, more cold air on the way, wrapping around it. That's the good indication that Baltimore to DC down to Fredericksburg would be the areas probably most likely hit by a significant snow amount versus west in the higher terrain or east to Chesapeake Bay. Had that low been 100 miles further offshore, then Dover, Delaware, probably down to St. Mary's County, Maryland, and down to Richmond would probably be in that heavier band, while lesser off to the north and west. Here's what the radar looked like overlapping with the satellite imagery. You can see in this area in Howard County and eastern and southern Maryland, northeast Maryland all together, it probably had started snowing a couple hours before that first low even left South Carolina. So you have all this time for that low to wrap up and all that moisture. Yes, sir?
What happened to the coastal low in northern Florida?
That low formed, I don't have a water vapor imagery loop where you can see like the little spins in the atmosphere, but that low formed on a piece of upper level energy that was coming in from the northwest. And what it's doing in the jet stream is carving out a trough from, I can't reach that high, but say from Wisconsin down to Tennessee, Georgia, and then up like this, like a big U. And that energy is riding down like that very quickly. And that energy, when it came down and had some pressure perturbations and temperature perturbations, it formed a low here, surface low. And then that low is going to follow the jet streams like this. That low is going to go north as well. With that low already in place, that's your pressure falls. So that low is going to catch up with the other one. And that's why you have one single low there, and the pressure is less. Pressure is less than, well, it says 997. Well, here it's 1,002 and 1,001. So two low pressures, 1,002, 1,001 became one stronger low at 997. Yeah, kind of a Fujiwara right around it. It just wrapped right into the storm and tightened it up in terms of its intensity. And hence you're getting that heavier band there from Philadelphia to Hagerstown down to DC with that particular setup. There is, I'm trying to think. There is a satellite imagery there. I think it's kind of like the water vapor imagery. It doesn't have that previous low in northern Florida in this sense. I don't have the map to go with that. But drier air is coming in from the southwest, like where that low is right now over Norfolk in this image. Drier air is coming across North Carolina. And drier air tends to eat away the moisture environment with that storm system. But also drier air tends to be colder too, because the dew points are less, and you're going to have that cold air coming in and wrapping up into the low. So you have a positive and a negative to it. The positive to it, it's colder air, it's going to reinforce the snow possibility and the amounts, but it's also dry, so you're going to eat away a lot of that moisture too. So how fast is that low moving away, and where's that dry air coming into it? February 13, 2014, here are some snow amounts. In this general area, I'm seeing anywhere from 5 to 13 inches. Where our office is in eastern Loudoun County, like a foot to a foot and a half. And so the bottom line on this is, as I mentioned, that where that track of that low between Hatteras and Norfolk occurred, the heavier snow tends to be from northern Baltimore County, southeastern Carroll, Montgomery County, down into just west of DC. So that band set up in that general area, and that's where your higher amounts are in terms of where that low went. And here are some observations from our storm spotters like yourself, our Kokoras, the public, might be a TV meteorologist in there somewhere, as well as broadcast media. That would be them, a private company. So we have a lot of spotters there and a lot of resources to give us a call and let us know what amounts they've gotten, and that's how we made that map that you just saw. Is we took those numbers there and plotted onto here onto a map, so we can see what the storm system was actually doing and what it actually did in that sense. And there was some ice too with that. So other notable winter storms, 2009, I came down to the region. I came with the Weather Service in May of '09, and I remember we had about 19 inches. I lived in Ashburn, Virginia, and I thought we were going to get about 6 or 7 because it doesn't really get these heavy snows in northern Virginia near DC. It doesn't usually happen. And I looked at the system thinking, we're going to get snow, no doubt about it, but I thought we were more like 6 to 8 inches or something like that. And we got hit really hard down there. And hence the track of this low and this track of this storm system, you can see the bottom left there, the low is over North Carolina. We had a coastal low come up, and then the bottom right, this is all, most likely all snow. This color green, that's your heavier snow, probably 1 mile visibility, heavy snow coming in. Some yellows makes it even more stand out even more. So storm ending, we had, let's see, in this area we had, looks like 14 to 18 inches in a good chunk of Howard County. In southeastern portions, it was more like, probably more closer to 14, 12 inches or 14. So it was a pretty nasty storm there. Follow that up in February, the first storm. This is one that I think both our area and Baltimore and here, Howard County got hit really good. But there's another storm, I want to say it was probably, this is when I remember the last one of the 3 of that winter season up here in the Baltimore, Howard County, and Carroll County got hit really hard, and we seemed like we didn't get hardly anything out of this. And this setup was nearly similar to the previous one, but I think a lot of dry air came in across the Blue Ridge of Virginia and ate away a lot of that possibility of snow amounts. We've gotten somewhere around 4 to 6, maybe closer to 8 inches. So those are the 3 nasty storm systems there. The Knickerbocker storm, January 27th, 28th, 1922, 28 inches of snow in DC, 27 in Baltimore, 30 to 32, Howard and Prince George's County, gusts of 50 mile per hour causing blizzard conditions, a roof collapse, and of course 1922, the warning system isn't as good as what it is today, and 98 people died from that particular storm, and a lot injured, probably from a roof collapse as well as hypothermia, anything like that. So it was a nasty storm. What was that, nearly a century ago? Preparing yourself for winter at home before the storm. As I mentioned, be prepared. So when you get that first alert from us from winter weather advisory for certain areas or winter storm watch. Be thinking about these items here and see if you have them. And it doesn't hurt to have them because a lot of them last a while. Bottled water and batteries usually doesn't go bad. So definitely take into account extra fuel for a generator, medications, batteries, water, so you name it up there. That's a lot of this is similar to what you would need for a hurricane. So just having a first aid, a gallon of water per person per day, I think is what is recommended for a hurricane. So why not have it for the same thing for the winter too? So basically having these on hand, no weather radio, baby food, stuff like that you would need before the storm system hits. If you're in the car before the storm or trip, make sure you have a cell phone and a charger, flashlight and batteries. Once again, first aid kit, a shovel, toolkit, blankets, blankets and sleeping bags, especially if you go off the road into a snowbank. If you're on a secondary road or secluded road, you don't know if anybody's going to pass by there in the next couple of hours. You want to be prepared for that. I literally, personally, before I became a meteorologist and was going to school, I literally slid off the road into a snowbank, and luckily for me, the shovel is what helped me out. It took me an hour, but shoveling the snow away from the tires just to get enough of a traction to get out. So snow shovels, kitty litter, bags of ice melt, stuff like that. Adding weight to your trunk if you have a vehicle or sedan, having weight in your trunk might help with traction. So just stuff like that. Think of it before the winter storm actually hits. Because as we found out from 09 and 10, 2013, or 2014, 2016, we get these big ones and you just never know if you're going to be the one affected. Fully check and winterize your vehicle before the season. Keep your gas tank near full. Let someone know where you are going and don't travel alone are always good helpful tips. Keeping your gas tank near full, keeping your gas tank even above a half a tank is going to help from your gas lines freezing if it's going to be really cold. You don't want to run low on gas, obviously for those reasons. You don't want to get stranded with a quarter tank of gas. Yet at the same time, if you get stranded, you got to be careful about keeping yourself warm by turning on your engine, because you don't know about the carbon monoxide issue. Is your tailpipe cleared and all that, or start it up for 5 minutes, 10 minutes, then turn it off, just to warm up. So just stuff like that. Some things are common sense, and some things are helpful hints to think about, well, what would I do in this situation if I was on a secluded road in Maryland or Virginia and I got stuck? Think about all these aspects in terms of safety. Heavy snow safety, big problem. Heavy snow, both in weight and amount. Heart attacks are common, especially for anybody really shoveling snow. Cold weather stresses the heart. Adding shoveling snow, pushing cars, walking through deep snow could cause those. So you definitely take it easy. Take frequent breaks. Pay the neighbor teenager who's looking to make a little extra money. Let them do it. It's one of those things where. We've had, in Virginia alone, I've had those big storm systems. I was renting, and I remember kids going around with 2 or 3 of them with shovels on their shoulders, and they would ask people, and they'd be like, yeah, and they shovel the snow away from the car. And yeah, it's just, you got to be careful. Give yourself some breaks. Think about hypothermia as well. When shoveling, move smaller amounts of snow, take frequent breaks, know your limits. Dress for the season. 50% of your body heat is lost through your head and neck area. Wear layers, wear hats, scarves, gloves, snow boots, basically staying warm and dry. Wind chill, not the actual temperature, but rather how wind and cold feel on exposed skin. Frostbite takes a matter of minutes, depending on how cold and how fast the wind is blowing. Damage to your body tissue caused by extreme cold. Frostbite causes a loss of feeling in white or pale. Appearance and extremities such as fingers, toes, earlobes, or the tip of your nose. And if symptoms present, get medical attention. Hypothermia, not just in the summertime, when we're looking in the spring into summer transition, and the water temperatures of Potomac and Chesapeake Bay are still really cold, and yet we have fishermen out there, and we have swimmers, and just people wanting a canoe, kayak. Hypothermia is an issue then. Now you're also thinking about winter time, where if you don't have the proper layers of clothes, wind-blown snow, hypothermia can occur very quickly. Some warning signs: uncontrollable shivering, memory loss or disorientation, incoherent, slurred speech, exhaustion, drowsiness are all factors related to hypothermia. And properly warming the body will drive the cold blood from the extremities to the heart, leading to heart failure. Condition brought on when the body temperature drops to less than 95 degrees. Some warning signs, once again, uncontrollable shivering, same things. Just keep in mind, hypothermia and frostbite are 2 big factors when it comes to the winter cold. If medical care is not available, warm the person slowly, starting with the body core. If necessary, use your body heat to help. Get the person into dry clothing and wrap in a warm blanket covering head and neck. Do not give the person alcohol, drugs, coffee, or any hot beverage or food. So just some indications there, and obviously you don't want to heat up too fast, too quickly. Injuries related to cold. 50% happen to people over 60 years old. More than 75% happen to males, and about 20% occur in the home and related to cold. I was trying to think in the home, and I got thinking, well, 20%, I would think most of those would be generators, where if you don't have properly ventilated areas, leaving the generator run, the fumes and everything. That's not good. So yeah, that most of the in-home occurrences is, I would think, is from that. But this is just the statistics that were found based on some injuries and medical care and stuff. If you're stuck outdoors in heavy snow, get out of the wind and try to stay warm and dry. Find shelter or build one with sticks and or snow, and if possible, build a fire, placing rocks around it to absorb heat. Eat high energy food. Do not eat snow. Melt it first and then drink it if necessary. If you're stuck outdoors in your vehicle, stay in your car or truck. Run motor about 10 minutes every hour for heat. Make sure the exhaust pipe is clear of snow. Open window, a crack to prevent carbon monoxide poisoning. Exercise from time to time to stimulate your circulation. And of course, tie a red cloth to your antenna or door to help indicate to rescuers that you're in trouble. I thought that was an Interstate National Guard should. That's not whenever we had that snowstorm and National Guard was taking our forecasters back and forth. That's a different, that was the different event there. And reporting criteria for winter storms. Reporting criteria, we covered this. So as spotters out there, and you've taken your basics class and now your winter class, and a lot of the severe criteria have come into mind. Ice accumulation, any amount. If it's glazing on your concrete sidewalk, but the asphalt is wet, let us know that. If you can break off a branch, see what the amount is based on a ruler or an estimation. Snow accumulation, first 2 inches, every 2 inches after that. Total snowfall at the end. Wipe your boards every 6 hours, no more, no frequently. And also mark your snowboards, obviously, some helpful hints. So we basically wrapped up this course for the Winter Storms course. Thank you for coming out and actually attending and getting more information from us in terms of what to do about winter storm spotting. 2 gentlemen here, Christopher Strom, Jeremy Geiger, are 2 gentlemen, as well as myself, that can answer questions about the course or about questions in general about our office if you're looking at getting tours. Before I answer a question, for those of you who are already hams or amateur radio operators or have an interest in it and maybe just missed the window of opportunity or want to know more about it, I have a gentleman here that attended the Winter Storms class. His name's Andy. He'll be glad to give you about 5 or 10 minutes on what you would want to know as an amateur radio operator, what and how they help us in gathering reports and what they do for us, especially when it comes to major storm systems, tornado outbreaks, winter storms, power outages. He can give you an idea on what the amateur radio operators do. So if you want to stick around for about 5 to 10 more minutes, I'll have Andy up here talking. Otherwise, I can take a couple questions right now. I know this gentleman here had one.
The PowerPoint's online.
Yes.
On the spotter.
Yeah, it should be on the spotter website. It should be a link on there of presentations, or it may actually be listed as basics, winter, flooding, tropical. If it's not, email Chris, Jeremy, or myself, and so we can get it to you, because I know. Oh, you did? A Dropbox. Okay, good. Yeah, so all the presentation will be on there. Are there any other questions? Yes.
I thank you and congratulate you for an excellent presentation.
Thank you.
A couple of your slides focused on an issue that I dealt with. Back in 1980, I began to build a log home in the Shenandoah Valley from a kit, and I looked at the regional snow that was compiled over the ages, and I came to the conclusion that 12 inches was sufficient to make sure that the roof would support a 12-inch snow load.
Oh, yeah.
However, when I checked with the Shenandoah National Park weather forecaster, I'm in Page County, near Luray, between Skyline Drive and I-81, on Massanutten Mountain. I found that in the 10 years before I built the house, snow's accumulation in excess of 25 inches had occurred 4 times.
4 times. On Massanutten Mountain.
On Massanutten Mountain, that's correct. So I had the architect design the house for a 30-inch snow load, figuring that it's going to probably occur when I'm not there.
Yeah.
So I won't be able to warm up the house, melt the snow, shovel it off, and so on. But it goes to point out that the regional projections don't always match up with what the local conditions are.
Mm-hmm. So our forecast area is massive in terms of the counties and the cities. And so this gentleman here talking about a house in a small area, Massanutten Mountain in Rockingham County, I think it is? Page County. And yeah, and just so our forecast, just like I said, if we're forecasting snow and it's not snowing, let us know. Or if we have no snow accumulation and you've already got 2 inches and it's still snowing, let us know those discrepancies. You know, and just like yourself, now you've been a spotter with the basics class and now winter class, you could be at that location and contact us with an accurate measurement, because yes, our forecast, our graphic that you would see there, based on your forecast, we could tweak that to where if you're getting so much more at such and such an elevation, we can have our map almost have like a bullseye in that area, because we have an actual ground truth of whatever 22 to 28 inches. We can do that and then extrapolate on our computer graphics and our forecast to make it indicate that, oh, you're at an elevation of, let's say, 1,500 feet or 1,800 feet, and everywhere along the Blue Ridge or whatever, west side or lee side, could have that same amount. We want to make that, because if we just have the Blue Ridge having 11 to 15 inches, now we have ground truth of someone getting 8 more inches than what we forecasted. We can adjust that quickly, because then everybody can say, oh, before we do this, let's check the forecast of Weather Service. Oh, wow, they're saying 18 to 24 right now. So that's good. That's good information. Thank you. And definitely everyone here being storm spotters, let us know what you're getting as the storm's going on, every 2 inches, any ice amounts, total snowfall at the end, anything like that. Give us a heads up on that. So I'll wrap up with that. Made good on time, but if anybody wants to hang around with amateur radio, Andy here will say a couple of words on it, and he might be able to elaborate more or answer questions for you. Thank you all for coming out. Appreciate it.
Thank you.
Thanks. Safe driving. Thank you.